Okay, this is radicals part 2. We're going to talk about multiplying radicals, dividing radicals, and simplifying radicals that are not square roots. But let's start with multiplying. Multiplying, the rule is multiply the coefficients with coefficients and multiply roots with roots. Let me show you what I mean. I don't have any coefficients on this problem, and I just have a square root of 6 times the square root of 15. So I'm just going to multiply those together. The best scenario, yes, if you multiply 6 times 15, you will get 90. That really doesn't help me any, because if I have the square root of 90, what do I have to do? I have to break it back down again. What is 90? 6 times 15. So I'm right back to where I started from. So what I'm going to do is I'm going to just not waste my time getting the larger number, and I'm going to put these two values under one big radical. 6 times 15. 6 breaks down into 3 times 2. 15 breaks down into 5 times 3. And I have a pair of 3's that I can cross off. Write it once on the outside. I do not have another pair, so the 2 times the 5, that just gets multiplied. And I have 3 times the square root of 10. Now, in the next problem, I have coefficients, and you have to keep in mind, coefficient times coefficient, root times root. I cannot multiply this 2 by this 8 or this 10. It's not really an 8, it's a square root of 8. It's a whole different value. So I'm going to multiply the 2 times the 3 and get 6. And I'm not going to multiply 8 times 10 and get 80 because I'm just going to break it right back down. So let's break down the 8. 8 is 4 times 2, and 10 is 2 times 5. But wait, there's more. 4 is 2 times 2. There's another 2, there's another 2, and here's a 5. So I'm looking for 2 of a kind. So I'm going to see I have a pair of 2's, cross them both off, write it once on the outside. Another pair of 2's, cross it off, write it once on the outside. What do I have? I have 2 times 2, which is 4. 4 times 6 is 24. And I am still left with a 5 all alone under the radical sign. Now, this is a fun one. Because yes, 8 times 10 is 80, and I could have broken that down. I have no clue what 14 times 63 is, and I really don't think I want to know. So I am going to multiply the 5 times the 2 and get a 10 on the outside. And then the 14 is just 2 times 7, and 63 is 9 times 8. So let's try this again. 10. 2 times 7, 9 is 3 times 3, 8 is 4 and 2, and 4 breaks down into 2 and 2, and 2. So let's see what pairs we have. Cross them off, write it once on the outside. There's a pair of 3's. I have a pair of 2's. Uh-oh, this is getting a little messy. Let me move my line so you can see this just a little better. And then I have another pair of 2's, so I have to write another 2 on the outside. 2 times 2 is 4, times 3 is 12, times 10 is 120. And I have this 7 all alone left under the radical sign. All right, now finally, sometimes you are given some trickier problems that are a little more complicated here. I have a product going on. I need to multiply. If you recall from algebra class, when you have 2 terms times 2 terms, there is a phrase that helps us remember how to multiply, and it is called FOIL. First, outer, inner, last. And that's the order that we usually multiply these values in. First means the first 2 terms, or the first terms in each parenthesis. So that would be the 2 times the 6, which is 12. The O is outer, that would be the outside terms, that would be the 2, times the negative 4 square roots of 2, Well, remember, coefficient times coefficient, root with root. 2 times 4 is 8. And I still have a radical 2, square root of 2. I is the inside term, so that would be a 3 square roots of 2 times 6. The 6 only multiplies by the 3, and we get 18 square roots of 2. And then last, this is the tricky one, the trickiest one, 3 square roots of 2 times the negative 4 square roots of 2. 3 times the negative 4 is a negative 12. Square root of 2 times square root of 2 is the square root of 4. 12 minus 8 square roots of 2 plus 18 square roots of 2. What is the square root of 4? It's 2. Negative 12 times 2 is a negative 24. All right, now we have to combine like terms. I have a 12 minus a 24. That would be a negative 12. I have negative 8 square roots of 2 plus 18 square roots of 2, which is a positive 10 square roots of 2. And there's my answer. So you have to be really, really careful with these. Multiply them out one step at a time. Please show your work, and hopefully if you do that, you can follow your steps as well. All right, let's try. Well, I have the word dividing here. I kind of don't like the word dividing because although, yes, a fraction does mean you are dividing, we're really just simplifying fractions on this type of problem. I have a few examples here. We have 2 different types of issues. The first 3 represent one of them, and the last one is a very different issue, but we'll get to that. When you're dividing, there is the number 1 rule. When you see a fraction, absolute, you can have no radicals in the denominator, none. So, square root, there's a flip side to that. Not only can you have no radicals in the denominator, you can have no denominator in the radical, which is actually the situation right here. I have a denominator underneath my radical. When you have, and as we showed in the multiplication, when you have one big radical, you can break it up into smaller parts. On the multiplication, we took the smaller ones and we put them together under one big radical. So I can look at this as the square root of 11 over the square root of 4. I'm just breaking it up into 2 parts. But I know the square root of 4 is 2. So I have square root of 11 over 2, and I'm done. That's my answer. Now, if I flipped this and made square root of 4 over 11, then when I break it up into square root of 4 over square root of 11, I get a similar answer. I get a 2 over a square root of 11. Well, I'm almost done, except for the fact that I know I can have no radicals in the denominator. None. That's a radical. It's in the denominator. So we have a problem. To get rid of it, the only thing I can do is multiply by 1. But I'm going to be creative in how I multiply by 1. I'll use pink. I need to get rid of that square root of 11. The only way to get rid of a square root is to square it. So what I'm going to do is I'm going to multiply it by itself. But remember, we said we had to multiply by 1. Otherwise, we're changing the value of the whole fraction. So what I do to the numerator, denominator, I must also do to the numerator. Now, you can see that's 1. Okay, anything divided by itself is 1. So let's multiply. When you multiply 2 fractions, you multiply straight across. So 2 times the square root of 11 is 2 square roots of 11. Square root of 11 times the square root of 11. Yes, it's the square root of 121, but what is that? It's 11. Now, do I have a radical in the denominator anymore? No, I don't. So that is my answer. Let's try the next one. This one's got a little twist to it because it has that 2 down there. I have a square root of 6 in the denominator. That's causing the problem. The 2 is not really a problem, just the square root of 6. So you know what? I can get away with only multiplying top and bottom by the square root of 6. If you multiplied them both by 2 square roots of 6, that will work also. But I'm trying to keep things nice and simple as best I can. All right, in the numerator, I'm going to think ahead for a second because I could get away with some things here. But when I multiply a square root times a square root, I'm going to have a 3 and I'm going to have a 6. And a 6 breaks into a 3 and a 2. So in the back of my mind, I'm going to realize, hey, that can simplify. So maybe I'll just look at this as 3 times 6. And then I can jump into the next step of actually simplifying it. If you wrote the square root of 18, you would be perfectly fine, but you're going to have to remember at the end that you need to break that down because you're not done yet. It's kind of like leaving 4 over 6. You can't leave 4 over 6. You have to reduce it. You can't leave a square root of 18 because it can still get simplified. 2 square roots of 6 times 2 square roots of 6. The 6's are both under the radical. I can cross them off and write it once on the outside. The 3's can get crossed off and write it once on the outside. So what do we have? We have a 3 and a square root and a 2. I have a 12 and no square root left, which is good because that's my goal. No square roots in the denominator. But I'm not quite done yet. 2 goes into 12, but be careful because that's not a 2. Looks like a 2, but it's not a 2. It's a square root of 2. And so I cannot cancel those out. That's a square root of 2, that's a 12, no. But I can cancel the 3 with the 12. That would work because they're both numbers, they're not roots. 3 goes into 12 4 times, and I am left with that. All right, last one. This one is a whole different thing because if I multiply top and bottom by the square root of 3, I'm going to have a problem because I'm going to get a 5 square root of 3, and it's not going to help me. So when you have a binomial here, what you're going to have to do is multiply top and bottom by the conjugate. The conjugate of 5 minus 2 square roots of 3 would be 5 plus 2 square roots of 3. All right, now, again, multiply straight across. So 7 gets multiplied by the 5 and the 2 square roots of 3, which is plus 14 square roots of 3. Now, back to something we did on the last board here. When I multiply these together, I must use FOIL. So, first, I hope you can see this, FOIL. First is 5 times 5, which is 25. Outer is 5 times 2 square roots of 3. That would give me 10 square roots of 3. Now, I said my whole goal is to have no radicals in the denominator. There's a radical, but hold on a second. The inside terms are negative 2 square roots of 3 times 5, which is a negative 10 square roots of 3. Ah, do you see what's going to happen? These are going to add up to 0, so they'll cancel out. And the last, be careful, negative 2 square roots of 3 times positive 2 square roots of 3 is negative 4 square roots of 9. Now, yes, ink marker, these will cancel. Okay, let me just rewrite my numerator. 35 plus 14 square roots of 3. I have a 25, and I have this fun thing. What's the square root of 9? Right, it's 3. 4 times 3 is 12. So I'm left with a final answer, 35 plus 14 square roots of 3 over 13. That was not fun. I get that. That was a really messy problem. But, I just messed up there. But we've got it. We worked it out. They're not always pretty, but that's okay. The final topic that I want to mention is how to simplify a radical that is not a square root. Okay? Cube root is, what I'm going to do is I'm going to do the exact same thing for square roots. When you are simplifying a square root, if you recall, and it's in the previous video on radicals, you are breaking everything down into all its factors and then looking for 2 of a kind. Well, for a third root, I'm going to take out 3 of a kind. For a fourth root, I'm going to take out 4 of a kind. So, here's my example. Cube root of 54x to the 5th. I need to break it down into all its factors, just like I always will. Do not lose this 3. I cannot suddenly change from a cube root into a square root. That's a whole different answer. So I have to remember to put the 3 there. Very important. 54 is 6 times 9. And I'm too lazy to write this multiple times, so I'll wait and do it here. Third root, 9 is 3 times 3. 6 is 2 times 3. And I have 1, 2, 3, 4, 5 x's. Now I am looking for 3 of a kind. I have 1, 2, 3 3's, and so that would go to the outside. And I have 1, 2, 3 x's, so that would go to the outside. Don't forget the 3 and the little nook there. I still have a 2 left over, and I have a pair of x's. That would be a 2x squared. Not too bad? Well, let's try again. Fourth root of 48x to the 4th y to the 5th. Uh-oh, I see a fourth root. That means I'm looking for 4 of a kind. All right, let's break it down. 48 is 6 times 8. And that's one way. If you thought 24 and 2, 4 and 12, you should get the same answer when you're done breaking all the parts down. Okay, I have 6 is 3. Whoa, I don't even know what that was. I was trying to write 3 times 2. 8 is 4 times 2. And 4 is 2 and 2. All right, 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, what do we have here? I'm looking for 4 of a kind. I have 4 2's. I have 4 x's. I have 4 y's. And all I have left is a 3 and a y. Again, I do not have the right answer. I am forgetting something extremely important. That says 2xy times the square root of 3y. I don't want the square root, I want the 4th root. Okay? So, just like kind of go back before you finish your answer and make sure you have the right value in there. And that's it. If I had a 5th root, I would break them all down and look for 5 of a kind. 10th root, 10 of a kind. That's it. Multiplying radicals, dividing or simplifying fractions with radicals, and radicals that are not square roots. Between these 2 videos, that's everything that we need to cover for this topic. Good luck, and let me know if you have any questions.